Hello everybody, my name is Frank. I'm with Boost, which is the graphics department of EMG. At Boost Belgium, we focus a lot on cycling. We deliver graphics for virtually all major cycling races all over the world. And today, I want to show you some cases about AR and AI and cycling during the Tour de France. I want to talk about three different stories. I want to talk about the pixel track. This is our first one. It's used by ASO in Tour de France, and it gives you the possibility to track a sprint up to 6 people in the sprint. It's a nice sprint evaluation tool, and it can be used live and in replay. Next one is our new team radio application. In this case, we record all the communication between the teams and the riders. It goes up to the cloud, it gets translated and turned into text. And it passes an editorial stage and let's call it a legal stage, because we don't want to show any technical decisions before they are actually happening. So this is the first time we use this in the Tour de France FAM in 2020. This is how it works. We record the communication, send everything up to the cloud. It will be converted to text, an editorial stage, and the final release to broadcast. Now, AI and cycling, very important. We work very close together with ID Labs, which is our research partner. It's closely linked to the University of Ghent, and it focuses on research on internet technologies and data science. They develop technologies outperforming current solutions for communication subsystems, artificial intelligence, and web seminars. So, AI and AR is not new. Since the early 2000s, I guess, there was already location-based advertising in static environments like stadiums, where, for instance, perimeter boards are showing a different commercial message based on the geographical location of the viewer. The challenge we have is to do this in a dynamic arena of cycling. The aim is to create a richer, adaptable, and more interactive reporting that could be exploited in a wider field. For instance, all this data that is generated could be used, could be used for cities to use in their city marketing. Sponsors could know where they are on the course and use those clips for their storytelling. We can use the metadata and visual assets generated by AI to enrich the broadcast and try to keep a younger audience interested. We can use it in training. This is a very short clip how AI is used during the event change in a medicine training. In this case, we use the information of the cadence, the frame rate, and the power meter, a gyroscope. It can only not predict the quality it can evaluate the quality of the change, but if it looks at the competitors, it can also try and predict when the other competitors are going to use the change. So it's an example for how you can use it in training. We use it a lot for safety as well. We have something that's called the course evaluation software, which in the input stage consists of an incident database. There's a course GPX file, there's Street View imagery, GoPro imagery, dashcam images. We can insert the parcours or the track, or even to eventually modifications to the track. All this data is processed in a geospatial, OpenStreetMap, and turn direction stage. The computer vision will divide the course into segments. It will detect objects. It will see cracks. It will detect similar circumstances and what happened under these circumstances. The output of the process can be a hazard score and the highlighting of dangerous point. How how it looks in real is like this. On the left, you can see the object being recognized. At the bottom left, you see the cracks in the road recognized, a prediction of a possibly hazardous point during the race, and you can see the final result in the race. Judging tools as well, we can flag behavior, we can flag dangerous behavior, we can have a library of similar sprint decisions when a certain behavior has taken place, and we can automatically map finish line videos. This case is a case of the 2020 Giro d'Italia where Viviani was disqualified, and to keep it very short, you can see on the graphic over there, with the purple line descending all the way down. This is Viviani getting off his line, and his actual position was very close to the predicted position of another rider. So he was disqualified from that race. And to see that in real time how it works, you can see the riders on the left and the plotting of the sprint lines on the right. There are also some broadcast tools. All these judging tools, of course, can be used in broadcast as well. We have a mode that detects how a rider is on his bike. We can do segment analysis, and we have AI-driven dashboards. This is an example of how a cyclist is recognized. Either he's running, he's cycling. You can see the spectators as well. This is an example of riding line detection. Every rider is plotted through the sandpit and can be shown afterwards in a nice graphic on air. There we go. And we can do segment analysis as well. In this course, the artificial intelligence decided there were 12 different pieces of soil. The last thing I want to show you is that all this data, all this gathered data can be compiled in data-driven dashboards, and we can do this as well, check which riders are popular on the road, and we can output them immediately to diverse social media. And the last thing I want to show you, I have to be quick, is our Boost Maps. And instead of showing you this clip of Boost Maps, we have a live demo with my colleague Tim here. And if everything goes well, you could see the map of London, of Earl's Cricket Ground right here. We prepared yesterday. So we basically can do a complete flyover of our area where we are. So Lord's Cricket Ground should be somewhere down here. There we are. And I think, Tim, the weather is a bit nice. I seem to remember that it was pouring rain this morning, so could you add some rain to the demo as well? So all these things can be done live. The director can fly, or the operator can fly all over the map. We can plot riders on the actual course based on their trackers. So it's a very nice and nifty view to show a course. You can show the highlights of London as well. And it takes us about 2 days to render a map like this and get it ready for broadcast. Again, it can be lively used in the broadcast. You can fly wherever you want, and you can see the riders, trackers, cars live on the track. There we go. Thank you very much.